Welcome everyone to Intro to JavaScript, Objects, Functions, and Execution Context. I'm Loralyn. I'm one of the engineering fellows on the West Coast campus. Thank you all for joining me tonight. So if you've been to the variables, looping, and control flow workshop, we talked about how variables allow us to store data, and that programming at its core is really just storing and manipulating data. So objects are one way that we can store data and also store functionality. And then functions are what allows us to bundle like lines of code that we want to execute over and over again. So objects are like a way of storing data, and functions you can think of as a way of storing a set of steps, a way of storing actions that you're going to take over and over again. And in the execution context, this is where all of our code runs in JavaScript. So look at kind of what that looks like when JavaScript code runs in our browser. And then before we dive into our JavaScript concepts, we're going to talk about just the main languages of the web. So these are HTML, CSS, and JavaScript. So we have markup languages, which are more presentational. So this means that there's not logic or algorithms to be evaluated. It's just basically a set of facts that tells the browser how to structure the data. So if we think about like a website as a body, the HTML would be like the skeleton and the muscle. So just like the structure, where everything is. The CSS would be the styles. So any aesthetic characteristics, hair, eye color, skin, clothes, even how we want things to look. And then on the other hand, we have scripting languages that handle the logic and give web pages functionality. So JavaScript is kind of the brain of our website body that allows us to carry out actions. Okay, let's get into it. So when JavaScript code runs, JavaScript reads from top to bottom, line by line, and it will store the data and then access that data using its labels. So looking at the code on the slide here, we are storing variables. So can someone tell me what the variables on the slide are?
Okay, so the variable here is sum.
Mm-hmm.
And then I guess variable could also be const, which we gave a label of my grades. Mm-hmm. And we assign an array of numbers. And then we reassign sum to my grades at the index of 0 plus my grades at the index of 1, and then my grades at the index of 2. Mm-hmm. And then we declare a variable average, and we assign sum divided by my grades length.
Right, yeah, thank you. Yeah, so the variables we have are sum, my grades, and average. My grades we declared with the const keyword, so it's a constant or a constant variable, you may hear it as well. So we have these keywords of let and const that allow us to tell JavaScript, hey, the next word here, we want you to store that as a variable, and then anything after the equal sign, the assignment operator, we want that to be the value. So these are going to get stored in our memory. So we are going to diagram this out on the next slide. Before that, I will just show again. So like Carolina said, this my grades is an array containing the numbers 50, 75, and 100. And arrays in JavaScript are 0 indexed. So each element in the array, each number in this array is stored at an index, and that starts at 0. So we have position or index 0, index 1, and index 2. So the leftmost element in an array is always going to be index 0, and then the next one will be index 1. So it starts at 0 like that. And then we can access these elements in our array using bracket notation, like we do here when we're reassigning the value of sum. So my grades at the index of 0 would be the element at index 0. So this would be 50 plus my grades at index 1, which would be 75, and then my grades at index 2, which is 100. So that's how we can access properties in an array, and then, or access elements in an array. And then all arrays have this length property. So this is built into JavaScript. So the array just tracks its own length based on how many elements are in it. So this array has 3 elements, so its length is 3. So the length property goes based off of how many elements there are, counting from 1. So the length will always be 1 more than the last index. It can be confusing the first few times you encounter that, but just know that that is what we've got there. And so my grades.length would just be the number 3. But we'll dive more into this on the diagramming on the next slide, but any questions just on the concepts in this code? Okay, so in JavaScript, when our code runs in the browser, it runs in what's called the execution context. And so I'll just represent that here. So we have our global execution context. And then within this global execution context, we'll have our global memory. So global memory will be where variables and other data get stored. And the execution context will be where the code gets executed. And so within the execution context, we have what's called the thread of execution. So our thread of execution is just going to keep track of where we are in the code. So JavaScript, as I mentioned, will read line by line. JavaScript is single threaded, which means there's just one thread of execution. One thing is executing at a time. And so we'll just go line by line through this code. Yeah, let's walk through this. So we are declaring a variable, which we know because we're using the let keyword. So we're using the let keyword to declare a variable with the label sum and assign it the value of 0. And so when we declare a variable, we're going to store that in our global memory. So we'll just have our sum of 0. And we don't need to bring the let keyword over here because we're just storing the variables themselves. And so then the next line, we're declaring a constant. Do you want to try and walk through that line?
Okay, then we'll declare a constant of my grades.
And we'll store that in global memory. And what is the value of my grades?
Is it just 50, 75, 100?
Mm-hmm. And yep, so the 50, 75, and 100, that is an array, which is indicated by these square brackets. So we'll have this array of the numbers 50, 75, and 100. Okay. And then the next line is kind of a tricky one. So I'll walk through this one. So we have sum again here, and we already declared sum on our first line. And here we have sum, but we don't have the let keyword. So we are, what we're doing here is reassigning the value of sum. And so that's going to happen here. So we're going to reassign sum from 0 to the evaluated result of adding all of the elements in the mygrades array. So these elements, as we said, will be 50, 75, and 100. And because this is kind of like functionality that we're executing, this will get executed in our thread of execution. And so sum will be reassigned to 50 plus 75 plus 100. And then as JavaScript finishes that, thread of execution keeps moving down, and this number that gets evaluated will get stored on our sum variable. So our sum now will be 225. And then Maggie, would you like to take a shot at the final line?
So then you're declaring the average and storing that in global memory. And then dividing 225 by, I'm not sure what you divide. I know you said it earlier, but I'm not sure what the length means.
Yeah, so mygrades is our array, and the length property is built into all arrays in JavaScript. So it's just the number of elements in our array. So we'll execute this over here. So we're going to have our average is going to be assigned the value of our sum, which is 225 here stored in global memory, divided by 3. And so we'll store that here on our average. So that'll be 75. All right. Yeah, Maggie, do you want to like try walking through it again now that you've seen it?
Yeah, so you declare the sum as equal to 0, and then
so declaring a variable called sum.
Oh, declaring why is it a variable? Just
so the let keyword and the const keyword are what we use to declare variables. So these are keywords that tell JavaScript that we're going to be declaring a variable, and hey, store this in global memory for us. So let is a value that can be reassigned, and const, which stands for constant, cannot be reassigned. So that's why on this line here, we can reassign the value of sum.
Okay, so you're declaring a variable of the sum is 0. Then you declare the constants of mygrades is equal to 50, 75, and 100. And then you're
an array.
Gotcha. Okay. And then you're redeclaring the variable of sum is equal to 75 or 50, 75 plus a 75 plus 100. And then you're redeclaring the variable, or no, you're just declaring the variable average is the sum divided by the divided by how many are in the array.
Awesome, fantastic job. Yeah, that is awesome work for your first time, especially. Yeah, great technical communication, and thank you for being willing to give it a go the first time. I was in your shoes about a year ago, so awesome. Thank you. All right, Carolina, do you have a question?
Yeah, this is Carolina. I do have a question. So when I see this explanation that is always like the global execution and the global memory and then the thread of execution, the question is just out of curiosity, does the thread of execution ever goes to global memory?
No, it's not necessarily like this concrete in JavaScript. So the thread of execution just represents where we are in our code, so kind of which line we're on. And then what will happen is, you know, when we got to this line where we're declaring our variable average, it is accessing sum. So, you know, JavaScript will be evaluating code here in the global execution context. And then when it sees the label sum, it's going to say, hey, I know that's a variable label. I'm going to go and look for that and find that in global memory. So it's not necessarily like taking a trip over to global memory and then coming back, but it has access to what's in global memory. I like to think of it kind of like global memory is like a closet, and the global execution context is like my room where I'm doing things. I'm working here, but I might need to, you know, get a book or get a sweater, and I know where to access those. Great question. All right, any other questions on this slide before we dig a little deeper? Yes, thank you, Mary, for the support in the chat. Love it. So we just walked through some code that we executed. What would happen if we want to use that same code over and over again? If we want to, you know, maybe we have 30 students who we want to average their test scores, and if we wanted to do that, we would have to write this code over and over and over again. But instead of that, we can store our functionality in a function. So I get a little deeper into what a function does, but a function basically allows us to take some code and run it many times. So again, we have a keyword, and y'all may have noticed like each of these kind of words here is in a different color. Also, if I say the wrong color for them, I'm colorblind, so just roll with it. But I think this is blue. So all of the keywords in JavaScript are in blue, and our labels are in this tealish color or purple or whatever it is. And so when you're working in like CSX or CSBin or any code editor, there's usually these clues of what all of these words are based on the colors. So when we are running code in a function, we basically get a new execution context. So we'll see this in the diagramming in the next slide, but when we enter into the code in a function, we open up another local execution context within our global execution context, where all of that code gets executed. And just to walk through this code, here on these lines here, this is basically, these lines are the code that we just executed on the last slide. So we're putting them all inside of a function called average grade that we can invoke as we do down here. This is indicated by the function name of average grade and then the parentheses after it. So that's invoking a function. And so when we invoke the function, then we'll enter into it and run all of this code. But then what do we do with that information? We will use the return keyword to get that out of our code. So on the next slide, we have just a refresher again on keywords, like I mentioned. So we have our keywords on this slide are function, which indicates that this is going to be a function. And our functions are always indicated by, draw it out. So we'll always have the keyword function, and then the function name, and then we'll have parentheses after it. And the parentheses is where we'll put parameters, which we'll get into further on in the workshop, but we can use it with no parameters, but the parentheses still go there. And then a function has curly braces wrapped around all of its functionality. So any lines of code within those curly braces are part of that function. And so the new keyword that we have here is return. So return is basically taking the rest of the expression after the return keyword, which here is just the variable average, and finding that value and returning it out as the output of the function. And then digging a little deeper into return. So our function, as we said, we save our lines of code with a label and run them later. We run the function by invoking it with parentheses. And it creates that new execution context with a little store of data. And then we use the return keyword to get that data out. So I know this is kind of a lot. We are going to go through and diagram this out. But any questions before we do that? Would someone like to walk through this code? Marcy, how are you feeling? You want to walk through this code?
Yes, I would love the practice. Thank you.
All right.
Okay, it looks like we're going to first declare a function average grade, which will open a global execution context and a global memory. And we will store that definition for average grade in the global memory as a function definition.
Cool. Can I have time to catch up now?
Sorry, I'll slow down.
Oh yeah, no worries. Yes, I should have prepared that before. So we have our global execution context, our global memory, and our thread of execution. Okay, so as Marcy said, we are storing our average grade as a function definition in global memory.
Since it hasn't been invoked yet, JavaScript would just read past all of the function definition and go to the second to last line, where we will then declare a constant variable with the label output and assign it to average grade. So now we're invoking average grade function, which will open a local execution context and a local memory.
Great. So this is, like I mentioned on the previous slides, when you invoke a function, it opens up its own local execution context and local memory.
Yes, and so the execution will move into that local execution context.
Mm-hmm.
And when that happens, we would pair any arguments with parameters, which this doesn't have, so we'll just ignore that. And we'll go ahead and declare a constant migrades in the local memory. And we will assign it to an array that contains the numbers 50, 75, and 100. Then we'll declare another variable sum and assign it to the number 0. So lots of stuff in the local memory now. And then sum is going to equal migrades at the 0 index, which would be 50. So this is going to be run in the local execution context, plus migrades at index 1. Is it index or indices? I don't know for sure.
Index. Yeah, indices is the plural of index.
Okay, thanks.
So, yeah.
Yeah, which is 75, like, yeah, and then migrades at index 2, which is 100, which would total 225. And then, yeah, perfect. And then we're going to declare another variable called average, and we're going to assign it to sum, which is 225 now in the local memory, divided by the length of migrades, which is 3. And so that would turn out to be 75. Very good. And we are going to then return that average 75, which means we would pop this off the call stack and it would return that to the global execution context under the label output in global memory.
Fantastic. Yes. So we are returning our average. So just clean some of this up and back up because yeah, fantastic work. Thank you so much. And I'll get back to the next line after I explain some things. So as Marcy said, we have our output. And so this is what started all of this was declaring this variable output in global memory and assigning it the value of the evaluated result of invoking our average grade function, passing in no parameters. So that opened up our local execution context and our local memory and moved the thread of execution into our average grade function. Because when we invoke the function, we are going and running that code inside of the function. But we don't have a value for output yet because we have to run through all of these lines of code first. So now that we have done that and we've reached our return keyword, we are returning average, which is 75. And we return that to exactly the place that asked for it, which was this output variable. So we will assign that to 75. And then the last thing Marcy said was that this will get garbage collected. So everything in our local execution context, because we have reached the end of this function, is going to go away. And garbage collection is the process that JavaScript uses for that. So really fun thing to call it. And that just basically says, this all ran, we have no use for it anymore. Toss it away, and we have our average was the only thing we wanted out of that. Okay, questions on that before Marcy walks us through the last line? All right, Marcy, let's pick back up on the final line.
Okay, so then JavaScript would continue on to the final line where we declare a new constant called with a label new output and assign it to the evaluated result again of average grade function, which is again going to open a new thread, a new local execution context and local memory, and the thread of execution will enter into that, and we would add that to our call stack.
Yes, that's the other thing. I don't have a call stack here, but the call stack is kind of the third piece of this. There's a lot more going on under the hood in JavaScript, but of the core pieces of it, the call stack is kind of what keeps track of where we are in the thread of execution. So on our call stack, we would start with the global execution context. So basically our call stack will be a stack of execution contexts. So on the bottom of our stack would be our global execution context. I'll just call this global. And then once we move it into
Our term is saying we push it to the call stack, right?
Yes, yeah. So the very first thing, like when this code starts running, we will push the global execution context onto the call stack. And then since we just opened up this local execution context by invoking average grade, we will pass this one, which I'll just call new output so that we can keep track of that.
Yes.
So yeah, that gets pushed onto the call stack, and yeah, let's pick back up.
Okay, and then JavaScript returns into that function and runs that code. So he will again declare a constant variable in the local memory with the label myGrades assigned to the array containing the numbers 50, 75, and 100. And then we will declare a second variable in the local memory with the label sum assigned to the number 0. And then in the local execution context, we will run the sum, which is currently 0, equal to my grades at index 0, which is 50, index 1, which is 75, and index 2, which is 100. Again, totaling 225. And then we will declare another variable called average and assign it to sum, which is currently 225 divided by the length of my grades, which is 3, which would then make an average of 75 in the local memory. Excuse me. And we will return that average out again as the new output, which would then pop off new output from our call stack and garbage collect all of that stuff we just did. And I'm just confused as to why we did that, because it didn't change anything.
Exactly. Great segue. Yeah, so each of these steps we take are kind of like, why did we do that? There's got to be a better way. And then we'll get into the better way. So we first started with, you know, we would have to just repeat writing these lines of code over and over and over and over again. And now we have our function, which allows us to call this with invoke the function on our output and our new output, but still we're using this my grades array of 50, 75, and 100. So that's not separate students. So what we're going to get into next is how to pass different numbers into our array. So yes, that's a fantastic question.
Got it. Thank you.
Awesome. Yeah, thank you, Marcy. Any other questions on this slide, this code? Jasmine? No?
Sorry, I accidentally unmuted myself, my bad.
Okay, all good. All right, so we will move on then. We'll go back to this slide because I have them out of order. So as Marcy asked, why did we do that? How can we make our instructions work on different grades? So just flipping back real quick, just to remind you that when we had this code here, our average grade, we had just empty parentheses after the function label, and then when we were invoking it. So what's different here on this slide is we have this my grades label in the parentheses here, and this array of 50, 75, and 100 in the parentheses when we're invoking the function. So what's happening here is that we have a parameter. So the my grades, you know, it looks like a variable, just like we declared on the others. It's just a label. But because it's in the parentheses of a function, it is a parameter. And a parameter is basically a placeholder for data that we're going to insert into the function when we invoke it. And so my grades, this could be called anything. It doesn't have to be called my grades. It could be called pizza or unicorn. We would just need to access it with pizza on this line here. Basically, whatever we call it here is how we'll access it within the function. So it's kind of like we're storing a variable in our parentheses here. It's not exactly what's happening, but a good way to understand it. If you know what a variable is, you can understand the parameter too. So that is the parameter. And then down here, when we're invoking the function, the data that gets passed into the parentheses is called the argument. And this is important. Parameters and arguments are different, and they mean different things. So the parameter is the placeholder in the function definition, and the argument is the actual information that we're placing into the parameter. So we will, I forget who said it, but somebody said if we had anything in the parentheses, we would pair our parameters with our arguments. So that's what we'll be doing. When we invoke average grade, we are basically going to be replacing my grades here. So when we invoke it, with this line here, we're going to be replacing my grades with this array containing 50, 75, and 100. And then when we invoke it on this line here, we'll replace it with an array containing 100, 85, and 100. So we'll get into diagramming this out on the next slide, but any questions on just parameters and arguments before we get into it? Okay. All right. Bethany, also welcome. I think you joined us a little later. So hello, welcome. Would you like to walk us through this code?
Sure.
Okay, cool. Thank you.
All right. So do you need to do any drawing first, or should I start?
Yeah, so yeah, like to set it up, we'll have our global execution context and our global memory.
Awesome. So we're going to use the function keyword to declare a function called average grade. And that will go in our global memory. And then further down, we're going to declare a variable using the const keyword. And this variable is called output. And we're giving output the value of average grade, which is a function with an array as a, oh, I forgot to mention the parameter earlier, but average grade has a parameter called my grades. And down below where we're declaring the variable, we're passing an argument through. Mm-hmm. And that will be, oh yeah.
Yeah, just to, how we would say this. So we're declaring the variable output and assigning it the value of invoking average grade, passing in this array containing 50, 75, and 100. Cool. So then what will that do?
So now we're invoking the function. So we're going to go inside of the function and open up a local memory. And in there, we're using the let keyword to declare a variable called sum, which will have a value of 0.
Just realized I didn't put the thread of execution in here, so I'll add that. Okay, and I'll draw the call stack since Marcy had mentioned it, and I'll back up because we did not do it at the start. So our call stack, when we first start running this code, we'll push the global execution context onto it. And then when we just entered into the function, we will pass our function execution context onto it. So we'll call this one output and push that onto the call stack. And then we enter into our local execution context. And I'll pass it back to Bethany.
All right, so, oh yeah, so we're using the let keyword to declare a variable called sum.
So before that, what do we do with this array?
Oh yeah, so we've passed that in as an argument. Wait, sorry, did something get, maybe I imagined it being written. We passed that argument through, but we won't be using it until after let sum, correct?
Yeah, and we basically, like, we can represent this in the local memory because even though it's not a variable, it is some data that's getting stored. So I'll just put that here. Okay.
All right, so now that we've already declared sum, but now we're going to take that same keyword, or sorry, that same variable, and we're going to give it the value of my grades at the index of 0, which is 50. And then we're going to add my grades at the index of 1, which is 75. And then my grades at the index of 2, which is 100. Which will be what was it, 225?
Yep.
And then we're going to use the let keyword to declare a variable called average. And we're going to assign that the value of sum, which is now 225. And we're going to divide that by my grades dot length, which would be 3. And all of this has been happening, and we've been only storing things so far in the local memory, but we're going to use the return keyword to pass the keyword average, or the value of average, into the global memory.
Great. Okay, so now we're at the bottom of the function. What happens next?
So now we'll go to the next line, in which we're using the const keyword to declare a new variable.
Yep. Yeah. Before that, we're going
to wipe the local memory.
Yeah. So once we reach the bottom of the function, the first thing that happens is our output, our local execution context, gets popped off of the call stack, which indicates to JavaScript that all of this local execution context and local memory can be garbage collected. And then, yes, now we are on the final line.
So we're going to use the const keyword to declare a variable called new output. And new output, the value is going to be average grade with the array 100, 85, and 100 passed through as the argument.
So that will push our local execution context onto the call stack. So I'll put new output here, and that will open up a new local execution context and local memory. And our thread of execution will move in there. All right, what's next?
All right, so now we're going to go back to the top. Oh, though 100, 85, and 100 have been pushed into the local memory now. And then we're going to declare a variable called sum, which has the value of 0. And then we're going to take sum and we're going to essentially give it a new value, which is my grades at the index of 0, which is 100 this time, plus my grades at the index of 1, which is 85, and my grades at the index of 2, which is 100. So 285. And then we're going to declare a new variable called average. And the value will be sum, so 285 divided by my grades dot length, which is 3.
I don't know what that is.
I don't know.
285
95.
divided by.
Perfect.
Thank you. Didn't do my math ahead of time.
And so right now we only have 95 in the local memory. And then in order to pass it into the global memory, we're going to use the return keyword to return average, which will contain that 95.
And that will get stored on new output. And then how do we get rid of this?
garbage collect the local memory.
Yep, so we'll pop off the local execution context from the call stack, and then garbage collect. Should have had a bigger eraser for this. And then, yeah, then we've reached the bottom of our code. Great work, Bethany. Thank you so much for getting us through that. Yeah. And yes, great dog too. Yeah, so this, by passing in parameters, what we did here is this allows us to invoke our average grade function more than once with different numbers passed in, so we can actually apply this to something that makes sense that we could use in real life. We don't really need a reason to, just repeat it with the same numbers over and over and over again. So we can pass any data we want into a function by using parameters and arguments and placing those inside of the parentheses. Any questions on this code here? All right. So next what we're going to look at is console logging versus returning. So the console, if y'all are not familiar with it yet, is basically another place within this this kind of under the hood world where JavaScript is running in the browser. So the console is essentially a developer tool that allows us to do more effective debugging or show error messages and things like that. So console logging just prints something to the console, and the console is something that you can see in your browser if you open up the developer tools, and then if you are working through CSX or CSBin, there's kind of that simulated console where you're console logging your data to so that you can see something print out. So the difference between returning and console logging is, so the return keyword, as we did in the diagramming on the last few slides, it will take that value, that 75, and return it back out to the global execution context to be stored and used in whatever way we want. Console logging is just printing it to the console. So it's not storing it in global memory, not storing it in local memory. It's just something that we can look at, basically. And yeah, so we'll kind of diagram out what this looks like, but any questions before we do that? Okay, so here we have our code. I will once again open up the global execution context and global memory. And the other thing we want to have here after the thread of execution. So these are, our normal environment places. So we've got our global execution context, global memory, and thread of execution. And then also over here in browser land, we'll have our console. So this will be where data gets printed. So yeah, let's go ahead and walk through this. Jasmine, would you like to walk through this code?
Sure. We're going to first declare the function, add function in global memory. And we are also going to declare the variable output. And I think for now that's going to be undefined. We're then going to go into our thread of execution. Sorry, global execution. And is there going to be a local execution context?
Yep. Anytime we're going to go into a function, we'll have the local execution context.
Okay, local execution context, and then there will also be the local memory. In the local memory, we are going to have, is it going to be add func with the values of 50 and 75?
So we have add func already in our global memory.
Okay.
And so we're actually within add func now. So the 50 and 75 exactly is what we need. So we'll basically be storing our num1 and num2 values. So we'll have num1, which is 50. And
50. Num2 will be 75.
And then just another note here, because this is a little different than what we saw in the previous one. So in the previous example, we had an array that we were passing in as my grades. So that was just, one array and one label of my grades. And here we have two separate values. We have 50 and 75. They are separate numbers. They're not wrapped in those square brackets, so they're not an array. And so we're passing them in as two separate arguments, and they're getting stored on two different labels. So we can pass really any number of arguments into a function. We just have to pair up our parameters and arguments as we did in the previous one. Okay, so with that sidebar, I will pass it back to Jasmine.
Okay, perfect. And then for this part, for the console log, would that go into the local execution context where we add num1 plus num2?
So the console log is actually just going to happen in the console. The console is like, I have it over here because it really is like separate from the rest of JavaScript land. So we, the thread of execution still takes us to that line, but we're just going to, I think I just answered the wrong question. That's not the question you asked. So I apologize. Yeah, so this will get evaluated in the local execution context. That's what you were asking, right?
Yeah, if num1 and num plus num2 go into the local execution context.
Yeah.
Okay.
So yeah, we will be executing that here.
Okay. So that's going to be 50 plus 75, which is going to be 125. So in the console then, would it store 120 or show 125?
Yep, exactly.
Okay. Yep. Perfect. And then I don't know what to do with the last console log, the last line. Oh wait, that just, it goes into the output. So the 125 gets, wait, never mind.
Yeah, so before this, we're actually going to, let's just leave this function. So we've invoked our add func as output, and then we've executed every line within add func. So now we can pop that off the call stack and garbage collect this local execution context. And because we had no return keyword, there's nothing that we're sending back to our global memory. So I believe you do know what happens here.
We console log that output, which is 125.
So output, where is output stored?
It's stored in the global memory.
And what is its value?
Will it still be undefined since we only console logged it? We didn't return anything?
Exactly, yes.
Okay.
Yeah, I knew you knew that because you said it earlier. So yeah, so this will console log the keyword undefined because we have not assigned any value to our add func. So that is kind of the difference between console log and return. Awesome work, Jasmine. Thank you so much. Any questions? All right. Yeah, so undefined, if you haven't encountered undefined before, undefined is a data type in JavaScript, just like numbers and strings and arrays and objects are data types. Undefined is a special data type that is just the keyword of undefined. So any variable or function output, anything that does not have a value that's been evaluated and returned, then it just automatically has a value of undefined. All right, so we have covered functions. We are going to get into objects now. So if you've been to any Codesmith workshops, you've probably heard that everything in JavaScript is an object. So you will hear this over and over again. Everything's an object in JavaScript. But what we're talking about here is really like the data type of object. So our objects are composite data types that can store information and functionality on them. So we'll look at the information part now and the functionality part in the next slide. So objects are made up of key value pairs called properties, and they are indicated by these curly braces. And our keys are always strings, but they don't need quotes around them. So they're just, they're strings, but you don't use quotes around the keys. The values can be any data type at all. So we have some strings, we have numbers, we have a Boolean true, and we even have arrays. So objects can contain any type of data. And an object, as you can see, is indicated by the object label, and then it will have curly braces with a key value pair. So you'll have a key and then a colon and then a value. And then between each key value pair, which is called a property, so there's a key and a value, those together are one property. Between each property, we have a comma, just separating the properties so that you don't get any syntax errors and things. To access any data on an object, we can use dot notation or bracket notation. So let's take a look at what these will evaluate to. So we have person.name here. So what this is doing is this is telling JavaScript to go look for this object called person and find a key called name. And so this would evaluate to will, which is the value stored on the name key. We can also use bracket notation. So with brackets, you would be passing in a string or a variable name. So if we had, if we had a variable that we wanted to look for that variable name inside of our object, you would omit the quotation marks. But here using bracket notation, we can access a property in the same way as the dot notation, where we will find our favenum key and access its value. And then we can also access values that are nested within our object. So as we saw in the previous slides, we can access elements and arrays using bracket notation. So here we have this fave snacks array, which has 2 elements at the 0 and 1 indexes. And so when we access person.favesnacks. This would evaluate to the entire array, but because we have the index, this will just evaluate to the 0th index, which would be twin snakes. Yeah, so that is basically objects in a nutshell. Any questions on how to access properties and like what an object is? Jasmine.
How would you access the keys? So like if we knew Will or Codesmith or 17, but we wanted to go backwards and figure out the corresponding keys to those values, how would we do that?
So there's a couple different methods that you could use. The methods as in built-in JavaScript methods, not like ways. Okay. So there is one called hasOwnProperty to look up that basically checks if that might check if there's a key, but also take a look at the object.keys and object.values methods. So these object.keys and object.values are methods on basically the object, on any object. And what these do is return an array of the keys or an array of the values. So I think that would be really the way to do it. These basically iterate over the object and return an array with all the keys or all of the values. And then you can also use there's a lot of ways. So a for of loop. And so basically this would look like, get some more space over here. So in a for of loop, we would say for, and then we would define a variable here. So we would maybe call it prop, for a prop of person. And so this is basically saying to look for, or it'll iterate over in the same way that a for loop would iterate over an array. And it'll iterate over all of the properties and look at each property in person. And then within there, sorry, this is getting a little sloppy, but within this for of loop, you can access, person at prop, and then just prop. So prop, I might have these backwards, but person at the key of prop would return the value and prop would return the key. I'd probably have those backwards, but definitely look up object.keys, object.values, and for of loops on MDN. And yes, that was kind of a sloppy sidebar, but hopefully that's helpful. Awesome. Any other questions on objects? Cool. So next we're going to get into storing functionality in an object. So we have pretty much the same object here. We have our person object with all of these same key value pairs. And this extra property that we've added here is the greeting property. Not quite right. So our greeting property is assigned the value of a function definition. And in that function, we have a console log of hello, everybody. And so the value of greeting is this whole function definition here. And we can invoke this in the same way that we can invoke any function. So this will just get stored in global memory. So I don't have a diagramming slide for this, but basically I'll just do a quick little mock-up of it here. So we have our global execution context and our global memory. And let's just clear out some of this. All right, that's not the cleanest thing, but it's what we have. So if we were running this code of our thread of execution, we would first get to our first line where we're declaring this constant person. And it would be an object with, name of Will, company Codesmith. So I won't repeat all of that. I'll just jump down to our greeting. So greeting would be stored in the same way. So greeting would be stored on this person object in global memory as a function definition. And then when we come down to the next line here, so person.name, this would just access the name property, but it's not being stored anywhere, so nothing would actually happen there. But if we had, let my name equals person.name, then it would get stored in global memory, but it's just there as an example. So then we would get to person.greeting. So this is invoking a function, just like we've invoked any other function. And so JavaScript's going to look in the global memory for an object called person. It will find it, and it's going to look to the greeting property and find it. And it will invoke that function because we have these parentheses after it. So then that will open up a local execution context and a local memory. And it will, where are we? Okay, so we're going into our function, and this function doesn't have a label. So it's just going to execute this console log. Which would log to the console. Hello, everybody. Yeah, so that would be the end of that function, and we would garbage collect all of this and then move on. So objects are super cool for this reason. We can store these functions. Console logging, hello everybody, isn't necessarily the most helpful function, but you can imagine if we, had our my grades arrays, if we had Will's grades stored on this object, we could also have a function that says execute all of that functionality from the previous slides. So we could store that whole function on an object and be able to access it with dot notation by accessing that property on this person object. We could also store our my grades array on this object and then store that function with it and really combine the storage of our data and our functionality. So that's really like the core of object-oriented programming, which is a pretty powerful concept in programming. It's something that's pretty common in other programming languages, and JavaScript is not necessarily an object-oriented programming language, but objects and functions on objects allow us to write code that is more like object-oriented programming. Can just be a pretty powerful way of storing and manipulating data. Any questions on objects and storing functions in objects? Carolina.
Yeah, so in this case, the name of the function is greeting, or that's just like the key. And
so this is actually, yeah, it's actually an anonymous function. So it has a key of greeting, and the function itself has no name. So no label. We could give it a label, just like we did with the other one, but this is just basically an anonymous function that we don't necessarily need a label on because we can access it through the greeting property. Yeah. All right. Any other questions?
I have a question.
Yeah.
On that same line, do we even need the keyword function there, or could it just be the parentheses?
So we do need the keyword function, or it could be an arrow function. So because it's an anonymous function with no label, it could be written with the keyword or with arrow function syntax, which if you haven't encountered that, looks like this, where you would just have parentheses and then this arrow that's an equals sign and a greater than sign, and then everything within it. So that's something that if anyone hasn't seen that, you'll encounter that later on in the CSX units. It's kind of a newer syntax for writing functions.
Thank you.
Yeah, you're welcome. All right. Okay, so I think all we've got left is some summary slides, and I'm happy to take any other questions as well. So just a recap of what we've gone over. We talked about functions and how functions can wrap up chunks of code to keep our code dry, which I might not have mentioned dry, but dry stands for don't repeat yourself. And it's basically just this programming principle of writing concise code that's not repetitive, so it's more performant and easier to read. So we talked about parameters and arguments and how to pair those up when we invoke our functions. We talked about the execution context. So JavaScript has our built-in global execution and global memory. And whenever we invoke a function, our local execution context opens up. If the function has a parameter, that gets stored in the local memory in that function level execution context. And then we talked about objects. Objects are these sets of key value pairs. The keys are strings, and the values can be any data type, including other objects. All right, well, have a fantastic night, everyone. Thank you so much for joining me. I loved attending these workshops when I was a pre-Codesmith person, so it's always a joy to give them too. Yeah, take care, everyone.